raise of hands, how many people here have used Bloodhound? Okay, good, I expect that. How many people have used Ghostwriter? Okay, nice. How many people have used Nemesis? Okay, and how many people have used Mythic or heard of Mythic? Okay, well, nice, okay. So those are kind of the broad topics that I'm going to be covering today, so it's kind of nice to see who has familiarity with what. So I'm Cody Thomas. If you do the Twitter game, I'm at It's a Feature. I typically do a lot of macOS research, red teaming, teaching, stuff like that. But I'm also a software engineer here at SpecterOps, where I spend most of my time nowadays working on Mythic and red team agents to go along with it. So today, we're going to be talking about the Mythic C2 framework, the kind of normal operational flow you expect as you operate on an engagement. And then we'll talk about what are some unconventional aspects you might encounter. We'll discover and talk about the Arachne agent for webshells. And then there's a new feature in Mythic that's coming out for third-party service agents. And so that's where we'll incorporate and talk about things with Ghostwriter, Bloodhound, and Nemesis. So first off, what is Mythic? Why am I even talking about it? Why do I make this? Why do we care? So Mythic is an open source C2 framework. The link is there. Pull requests are always welcome. It uses a microservice architecture with Docker. So the whole point here is that you as an agent developer can focus on what you care about most, agent development. You can just plug in your agent and Mythic takes care of everything else. It handles backend, user authentication, UI, scripting, like all of that handled, abstracted away from you. You can just worry about that one piece. So as part of that, if you actually install Mythic, there's no actual agents or C2 profiles you get. It's all plug and play and helped out a lot by the community. So I'll show here in a couple slides some of the agents that people have contributed. With this, there is a collaborative web UI that you connect up with. Everybody has their own login information with access control. So you can have lead operators, normal operators, spectators, all sorts of stuff. There's a Postgres database that saves everything for you in the back end. And the UI and scripting both use GraphQL as a kind of API access point. So just a kind of introductory shot here of the main homepage dashboard for Mythic gives you a high-level overview of kind of the stuff that you'd want to see as you come into an operation on a morning. How many callbacks do you have? How many have called back in the last hour or so? What kinds of commands are people running? Which ones are failing? What kinds of things do you need to troubleshoot? All sorts of stuff like that. So with this, and Mythic being a kind of community event, there's a whole bunch of agents that people contribute. So this is a public website modeled after Cobalt Strike's community kit, where you can see everything that people are contributing to Mythic in the community, along with how recently they've done these commits. So you can see like Freya and Thanatos, Athena, Hermes, like all these are agents that we at SpecterOps have not created. These are just community things that people update and add into it for us. With this, you may be wondering, okay, that's fantastic. I see these 5 agents have updated in the last month. What do they do? Or how do I know which agents or C2 profiles I should actually install to accomplish my objective for a macOS engagement or a certain Windows engagement? Well, up here at the top, there's that capability matrix. If you click that, it gives you a handy breakdown of what specific capabilities each agent provides, so you have a clear way to compare and contrast across all of them for whatever it is that you're trying to leverage. Now, Mythic overall has what looks like a complex flow diagram, but again, these are all just the components that come together that provide that robust UI for you. So everything is hidden behind a reverse Nginx proxy. So you just have one interface that you connect up to, and you get proxied back to the web UI, that GraphQL scripting aspect. The back end for Mythic is in Golang. So it has a Golang web server using Gin that goes through and handles kind of the authentication and brains of agent processing. There's a Jupyter notebook in here that has a whole bunch of scripting examples already set up for you. In addition to all the agents come with their own internal documentation. Trying to have a community with all their own disparate commands and stuff like that, that gets a little troublesome to include in the main UI. So there's an included separate web server just for documentation on all the agents. That's here. We have the Postgres database and RabbitMQ that goes through to allow all these various containers to connect and talk to each other. And then of course, that's just Mythic core. The things that people are contributing are payloads, C2 profiles, different containers to handle how logging happens, and different containers to handle how webhooks happen. So lots of different stuff. Today, though, we're going to be just talking about this little corner here, just these payload containers. So again, why does Mythic matter? Why are we talking about all of this? So with this, as an agent developer, you get full control over how tasking works, how building payloads works, those environments. You can process the responses that come back from your agent however you want. You can manipulate the data that comes back to display things like tables, buttons, further on tasking, all sorts of stuff instead of just strings that you get back from like a dir listing. You also can adjust and do whatever kind of message format you want. Mythic uses JSON. Maybe you hate JSON and prefer some binary serialized format or something else. Fine, you can use that in your agent and go about your day, not having to worry about it. So if we look at the normal operational flow, there's a couple of different steps. So you set out to do a red team. All right, first thing you do is you need to pick a C2 framework. In this case, let's say you picked Mythic. You install the C2 framework, you install whatever agents you're going to use, you generate your payloads, and you detonate them on target. Now there's two kind of patterns that you could take here. The first one being a beacon or polling mechanism where your agent is reaching back periodically. So your agent phones home, you get a new connection. All right, I have a new callback. You issue a task, the agent phones home again, picks it up. Sometime later, the agent phones home again, sends the response. That's kind of your standard operational flow. There's another kind of way you can do this that's a little less common, but still useful, as a push style. So instead of having the agent beacon back periodically asking for tasks and stuff like this, it can instead hold open a connection, and then Mythic or your C2 platform can just push data to it as it becomes available. This reduces a lot of the overhead of having to ask for the same thing over and over and over again. Lots of times, if you have an agent that has maybe a sleep of 1 or 2 seconds, most of those requests that it's doing is the same generic blank response back, nothing submitted, nothing submitted, nothing submitted. So if you can reduce that and just have a held open connection, you can do things this way. You get your one phone home, connection set up, you type a task, get sent down. So the way this looks in Mythic is you as your operator over here issue some sort of task. It goes to Mythic. Mythic validates with its role-based access control. Are you allowed to submit this task? Is this something that you can do? It will then create the task in the database and forward that along to your container. At this point, you as the agent developer have full control. You've identified what parameters you want. You've identified how processing happens. You identified what kinds of scripting, if you want to hit Mythic's RPC interfaces and create new entries and build new things and do whatever you want. All this is available for you here. There's also 2 pieces in here for an OPSEC pre-flight and post-flight check. So say, for example, as part of your tasking, you want to send down a file to your agent, and maybe you're building that dynamically. As part of these pre- and post-flight checks, you can say, okay, you've generated a file, but before we actually let the agent pick that up and do something with it, let's make sure that we don't have bad strings in there. Or if we did this as open source code, let's make sure we pulled out people's handles, stuff like that. You can do these sorts of checks dynamically. So with, as part of this, you're going through and you're controlling how tasking happens and all the various pieces here. Maybe you send back strings, but ideally, it would be nice if you could send back structured data. So if you could send back for a file listing, not just the plain text dir output that Microsoft returns, but actually JSON data or something that's a bit more meaningful. That's great and all, looks something like this, but you as an operator would probably hate this. This is a lot harder for you to kind of grok and parse through. A simple dir listing is better. But the nice thing about the way Mythic allows you to process things is you can add browser scripts, which allows you to say, at the UI level, getting data back like this, let's instead do something more meaningful with it. Let's turn it into a table, for example. So we can take this and say, okay, we got back easily processed structured data. Now let's turn it into a clickable table with filters and searches and sorts and all sorts of stuff that's more meaningful for an operator. So this is what I'm coming from as the standard operational flow that you would use, okay? Lots of these different components. So if that's standard, what is non-standard? What is unconventional? Well, let's take a different kind of agent. Let's look at a web shell. So web shell, very common in pen testing and red teaming. You go through typically some sort of upload or process injection. You get your malicious like website code hosted on the server. you can then do gets and posts to that web page to typically execute things. So that's what we have here is a little example. It is a web page that just expects a CMD, a command parameter. If it sees it, it goes through and executes it on the system and gives the data back. Pretty straightforward, right? However, this isn't that conducive to you operating from a C2 platform, right? If you have a web shell like this, you typically have to start doing curls or open up in your browser and start interacting with it outside of whatever C2 platform you're using. So the reason you have to do that is web shells don't phone home. Like either of those two instances that we were talking about before, beaconing or one held open connection, requires an agent to phone home. That doesn't happen with a web shell, it's just sitting there listening for you. If you can't even get an agent to phone home and get a callback, how are you going to task it? Because there's nothing there for you to task. As part of this, what if that web shell that you're trying to access isn't internet accessible? What if you have to access it through an agent into an internal network? Well, that adds even more complications to all this. So let's see if we can find a way to make this a bit easier. So as part of this, I think last month, I released an agent called Arachne. Arachne is a web shell agent for Mythic. It has two languages, ASPX and PHP, so you can do this on Windows or Linux. And of course, you can add in other languages and stuff as you want. It supports full AES 256 HMAC encryption, so you don't have to worry about things going across in plain text. And by default, it has a variety of commands, upload, download, ls, execute, stuff like that. If you are using the ASPX Windows version, you can actually do execute assembly and upload full assemblies and execute them there. So lots of features, but we still have some problems that we need to overcome to allow us to use this in a C2 platform. So problem number one, there's no callback, right? Your agent isn't phoning home. So how are you getting a callback in the first place to even task it? So what we can do in Mythic is we can kind of precede a fake callback that eventually will resolve to some web shell that you have listening somewhere. So what we can do, either as part of the build process, there is an RPC endpoint that you can hit that says, hey, when you try and build an Arachne payload, just generate a fake callback. All the data will be blank, like your user, your IP, stuff like that, because you don't know yet. But you can at least then have something in the UI that you task. If you don't want to do that, for any payload that you've created, you can also come down here to this little generate callback and supply any of the data that you want, IP, host, user, anything that's meaningful to you, and generate a callback that way. So what this looks like in the UI looks just like any other normal callback. The last check-in time, of course, will just be whenever it was created. There's nothing phoning home, so there is no last check-in time. But now you have a callback. That was the first problem in general. You have something now that you can task. And because we created this off of a payload, that payload has encryption keys and everything set. So we have all the encryption and callback information necessary to now start tasking it. So that next piece, how are we issuing a task? If we submit something normally, there's no agent phoning home to then pick it up and then execute it on our behalf. So what we have to do is from our payload container, actually make the web request ourselves. But we can do that because as part of the container, we have full execution control of how we want our agent to work. So what we can do here, little example on the side, where we just take a couple of steps. We take the message that we want to send to the agent. It expects it encrypted. So this first thing that we do up here is we just say, hey, here's a message. Mythic, please encrypt this for us. It goes through, does the AES-256 HMAC encryption for you. Fantastic. Now we just do our standard HTTP web request to our web shell that's living. We get back an encrypted response. So ask Mythic, hey, here's this encrypted blob. Please decrypt this for me. And now let's do something with the data. In this case, this is a check-in message. So we created that fake callback with no meaningful data. We issue a check-in that says, kind of like a Cobalt Strike DNS C2, has no data, you say check-in, and it gives you back the proper PID, host, IP, all that sort of stuff. So that's what we're doing down here. The Arachne agent, instead of using JSON, does pipe delimited fields. So we just take that, split on pipes, and update via Mythic RPC to say, hey, you know what? I had this, I issued check-in, I got these fields back. Here's my OS, my IP, user. This was a Kali box in this case. And we automatically update the actual callback up here. So now we have full execution and tasking on this agent that doesn't phone home to us. Now, the last thing was, what if this agent isn't publicly accessible? What if you compromise this on an internal website that you then want to leverage and start doing things that way? Well, there's two things then that we need to kind of handle in this case. If an internal agent is going to connect up and issue tasks for us, there needs to be a peer-to-peer profile, a way for that agent to know how to talk to another agent. On top of that, if we're doing things now having Mythic pick up the task for us instead of our container just making the web shell, then we have to have some way to convert between Mythic's JSON and just this pipe delimited stuff that we're trying to send to the agent. So what we can do is we can create a peer-to-peer profile in Mythic. This is just another container that you connect up. We identify what information would be useful for that peer-to-peer connection. So what is the cookie information that I'm sending? What's the user agent that's needed? Are there any query parameters? The sort of stuff that you'd normally be sending as part of your web shell. We then take that and we say, all right, now I want to have my agent, in this case Poseidon, I want to link to that web shell. Normally for a peer-to-peer, when you try and link, you're like holding open a connection or talking over SMB, stuff like that. This is, of course, still just a web shell. So all you're really doing is saying, hey, Poseidon agent, or hey, other agent, here is how you will make this specific kind of web request to this internal compromised website that we're using. Then at this point, now you have your peer-to-peer graph. So you have a web shell agent that's linked over a web shell peer-to-peer profile to some other agent. At that point, all we need to do is simply convert between JSON and our pipe delimited data. This is super, super easy. Mythic calls this translation containers. You don't have to worry about any of that. All we're doing up here is we say, all right, I'm trying to go from JSON to pipe delimited. So let's just remove all the JSON components and just send the actual message. Same thing on the reverse back down here. Let's say I have all this pipe delimited data. Let me split on those pipes and now convert it back into JSON that Mythic uses. So all of that, we're now able to create callbacks without needing an agent to phone home to us at all. We can take these callbacks and issue tasks with completely custom logic. Like we're bypassing a lot of the stuff that Mythic normally does and just saying, here, reach out to this web shell and send data and then decrypt it. And as part of this, if you're issuing these tasks through Mythic, now this kind of solo experience of giving tasks to a web shell is now something that you can do collaboratively. You and your other teammates can see what requests are being sent, the responses are being captured. All this makes it a bit easier to do deconfliction and collaborate on what you're doing. So with this, there's kind of a next logical step, like why stop at web shell agents? Well, there are a lot of other things that work similarly, so let's start talking about that. So Mythic is including now this kind of third-party service agent. So if you start looking beyond operating of just what kinds of agents are you doing, what other things are you doing in general as you operate? You typically are tracking your logs, objectives that you're doing, your findings, or what artifacts are you dropping to disk, all these sorts of things you're having to maintain somewhere. Here at SpecterOps, we add in a lot of this into Ghostwriter. You may have additional tooling that you're using, like Bloodhound or Nemesis, to aggregate this data and get more insight into what's happening. You'll probably have something for team collaboration, Slack, Mattermost, Rocket Chat, like whatever it is that you're using. You might have to be writing your report in line as you're operating. So being able to speed up that process is really helpful. And you might have additional infrastructure management. Like partway through an assessment, you may find that your domain is burned and you need to stand up more redirectors or change configurations. Like all these sorts of things you're having to do on a daily basis that take you outside of your normal C2 platform. So you're having to hop between tabs or different programs altogether. The problem with this is you end up with a lot of duplicated entry. You're having to copy and paste things, or you're manually typing things in from one platform to another. That's error prone, it's tedious, it gives like context switching overhead and tiredness to operators that makes them more error prone. Like there has to be a way that we can make this a bit easier. So what Mythic has decided is that since we already saw how you can interact with a web shell. A web shell is just a different service that's listening for web requests. Well, that's no different than interacting with an API for some other program. Well, why don't we take the same sort of stuff that we did for Arachne and apply it to these other things that we're leveraging? So the main difference here is that with Arachne and with webshells, you're authenticating, but it's really just like your C2 server authenticating. Ideally, for these third-party platforms, we want to be able to authenticate as myself, not as Mythic or this specific Mythic deployment, but I want my access to be different than my teammates' access to our shared reporting platform, for example. So we want to be able to have a way to capture that nuance, but still have a way that you can issue tasks right in line as you go about, actually controlling agents. So is there a way we can go about doing this? Well, that first thing that we need to tackle is how we're going to differentiate myself from my partner in terms of these third-party services. So we don't want to have you create API tokens for these services and drop them on disk. We don't want to have them in like env configs that anybody can read on target. We want this to be a little bit more protected and a little bit more user-specific. If you add a new user to an operation, we want them to be able to hop in and use these services as well. So what Mythic does is if you go to your user settings, there is now this little key icon. You can click this and view just your user-specific keys. So these are your secrets that you're configuring, your key value pairs, just kind of like secrets that you'd have for GitHub Actions or stuff like that, any sort of CI/CD stuff. And these secrets then get sent down as part of your tasking for issuing tasks to your agent. That means that now as part of that control flow where you are making your web requests, you have access to the user-specific data. Fantastic. So let's figure out how we can leverage this to make our lives a little bit easier. The first kind of case study here is using Ghostwriter. So we use this a bunch internally. We use it mostly for Mythic Sync in this specific case. So Mythic Sync is a script that you can go ahead and set up with Mythic that goes through and registers Mythic's API to listen for new taskings and automatically ingest it into the oplog entry. So you inherently get free task logging, which is fantastic. But there are other things that we want to do on top of this, right? As you're operating, you are adding objectives or marking objectives as complete. You're tracking new tasks or things as evidence for the stuff that you're doing. You're registering new findings, all this sort of stuff that's outside of just simply tracking, hey, I issued this command at this UTC timestamp. So all this sort of stuff, because Ghostwriter has an API, we can also leverage right from tasking. So as part of this, you'll need two things mainly. So you need to, in Ghostwriter, create your user-specific API token. Okay, easy enough. And then you need to tell Mythic where Ghostwriter lives. Okay, that's, an easy ask. You should know where it lives already. You're accessing it. So you can use these to then build your agent. So in this case, just like we saw with Arachne, where you can make a fake callback, we're going to do the same thing and say, hey, here's a fake callback from a Ghostwriter instance, which is never going to phone home to you. It's its own separate third-party platform. But now you can issue tasks and tell Ghostwriter to do things for you. So just some examples of things that we have added into this Ghostwriter agent. You can manipulate findings, you can add new findings, you can attach findings to reports, you can change CVSS scores, all that sort of stuff. You can track new objectives, mark objectives as complete, all of that. You can create new evidence, delete evidence, update evidence. We use the oplog already with like Mythic Sync, but you can search the oplog, you can edit the oplog entries, you can do all that sort of stuff right in line. And of course, you can modify and manipulate your reports. So what does this look like? Well, it should look like just any other tasking that you do in an agent. And remember, because we are getting API level access, we're hitting Ghostwriter's API, but now we're getting UI control. We can do API level things with more user-friendly interfaces. So here, we're hitting Ghostwriter's API, getting back GraphQL data, and we can turn it into these actionable tables. So you can see here all the findings that we have, their Ghostwriter colored specific severity levels, whether it's completed, who's reviewing it, all this sort of stuff. You can just update it in real time as you're going along and operating. Same sort of stuff with objectives. You can see what's going on, what objectives you still have left to complete, all of that. You can go through and search your oplog entries. You can edit them. You can see like, oh, did this thing happen, or what kinds of things have we done on specific tools, all that sort of stuff readily available. And of course, you can go through and manipulate the evidence. So this is one of the things that's a bit tougher to do as you're operating, you do something, you issue a task, now you have a finding, and you need to go and make some sort of evidence for that finding of what you did, when you did it, maybe a screenshot, like all that sort of stuff. You can start doing a lot more of that now in this agent right from your normal platform. Now, of course, you can always go to Ghostwriter directly and polish and edit and do a little kind of cleanup around the rough edges, but this allows you to get a lot of that kind of inline reporting done for you without breaking your main operational flow. The other big one I really want to talk about is Bloodhound. And I know a lot of people here use Bloodhound. It's freaking awesome. There are just some added benefits that we can get if we can talk to Bloodhound from within our C2 platform. So specifically with Bloodhound's Community Edition, super awesome, helps you find a lot of these attack paths, uses graph theory to find shortest paths between nodes. It collects a lot of awesome data that you can represent. The nice thing is it focuses on edges and paths that are actually abusable, not just theory, but things that you can actually do, which is nice because from a C2 platform, we're interested in actually doing things. We're trying to run things on agents. So in this Community Edition specifically has Docker, which I already like because Mythic uses Docker, and has its own Postgres database and a React Web UI. So that's fantastic. There are some pros and cons though. So the Bloodhound CE UI can display a lot of nodes, can display a lot of edges. It's easy to click around. You can see a lot of the related metadata, all sorts of stuff along with it. It has a really nice, clean UI for how you're going about doing things. The downside is that that's not a collaborative UI. If I'm clicking around in a Bloodhound graph or searching things and I want to share that with a colleague, we need to hop and share screen so you can see what I'm clicking. I can't just like send you a link to then see what it is that I'm seeing. You can't backtrack. So if you click down into certain data and you want to go back to that original query that you used, you can't easily hop back and see what was going on. So your kind of thought process along the way to finding maybe a vulnerable target or an ideal attack path gets lost along the way. Once you get some data, it's not necessarily easy to go through and prune it back to see, maybe you had some Cypher query that pulled a lot of data, but only part of it is what you're interested in, to try and like prune that down to something that's a bit more manageable. You can't task agents through this, so this is a whole separate UI. So if you find something that you want to target, you then have to like copy SIDs and usernames and stuff and go into whatever platform you're using and paste it in there and do all of that. So that requires a lot of context switching. So with Bloodhound Community Edition though, there's now an API. I love this. This means that we can go through and hit this API the same way that we're talking to Ghostwriter. So the nice thing, Bloodhound Community Edition provides a easy Python example of how to go through and communicate and get API tokens and all this sort of stuff, so you can get up and going pretty quickly. This is an example from their internal API docs that allows you to search for the endpoints and the data and stuff that you get back. So just like with the Bloodhound agent, all we really need to do is for your user, go through and generate your API token. And whenever you create this kind of fake agent callback, you just need to tell Mythic where Bloodhound lives. So that's all you really need to do. We can see here, we're building a payload type for Bloodhound. We just tell it, where the Bloodhound actually exists for us. And now we can start doing a lot of awesome things. So we have access to Cypher queries. You can access your saved Cypher queries, the predefined ones. You can get information about objects. You can upload new, you can upload new JSON files to Bloodhound straight from Mythic. You can find shortest path. You can find outbound controllable, like all sorts of stuff that is available in the Bloodhound UI. They have exposed through API that we can then write commands and interact with. So remember, Bloodhound works in graphs though. A lot of what we've seen so far in the UI controllability for Mythic is looking at tables. Well, why don't we just also add graphs to Mythic's UI? So the new Mythic now has an option for you to take this structured data and not just return tables for it, but return nodes, edges, properties, all sorts of stuff on these things that you can then render in the UI. Now, remember, one of the things that I said that Bloodhound CE UI does really well is it allows you to display and render a lot of nodes and edges pretty performantly. Mythic is not Bloodhound UI. So Mythic goes ahead and says, if you try and render a graph that has more than 50 nodes, it may work just fine, but it may slow things down. So it will automatically collapse and hide those graphs for you to explicitly allow, like, okay, yeah, if this takes 5 seconds to render because I got, 350 nodes, I'm okay with that, and then it will display it for you. But that's just kind of, as you go through doing a lot of these queries, not freezing your UI as you're trying to render this sort of stuff. So what does this look like? Looks just like this. You can go ahead and see the various icons, and you can do overlay icons for like the high value targets or, nodes that you've marked as owned, just like you expect in Bloodhound. And you can see the paths for what's going on. So we can see here like local admin, member of domain admins, all this sorts of data readily available for you. Down here on the side, there are some helpful buttons for you to zoom in, zoom out. You can auto size things to your view. You can also, whatever you currently view, you can save as a screenshot. So whatever you finally prune things down to, you can just save that off and use it as evidence further on. And over here is a little mini map. So it shows all the nodes that are currently represented and how far in or out you're zoomed. And so instead of trying to click around and scroll in the UI, you can just use this little mini map and drag this little center square here to change whatever it is that you're trying to look at. Now, this is a really small graph, right? There's only a couple of nodes. What if you have something a bit more complicated? So lots of things going on here. It's hard to kind of figure out what it is I'm looking at, or if there was one specific node I was interested in, like what can it do? Well, with Mythic, for these nodes, you can go ahead and select any individual node, and you can hold Shift and select multiple nodes and see just what they have inbound and outbound control over. So that makes it a lot easier to kind of condense these more complicated graphs into something that's easier to understand. On top of that, you can hide and have custom actions for these nodes and edges. So we can select 5 nodes that we're interested in and say, hide everything else. And all you'll see is those nodes and their paths. So it makes it a bit easier to go through and kind of prune down a noisy query to what it is you're actually interested in looking at. You can also go through and view all the additional data that comes back as part of Bloodhound's API. You can mark certain nodes as owned or unmark them as owned, depending on what it is that you're doing as part of your operations. Same with the shortest path and stuff like that. So if you go through and you take a graph, you can then prune it, and now you can see that same graph is much easier to see the specific path I'm interested in. And now I can take a screenshot of just that path to then include as part of like a report or things like that. So it makes stuff a little bit easier. But the nice thing about being able to have Bloodhound inside of Mythic is that you can start leveraging Mythic agents to do things. So Mythic already provides a way for you to go through and task agents via buttons in the UI. So instead of you on the command line typing out a command, you can just click a button and Mythic will figure out automatically what command it is you're trying to issue. So we can see these things down here with like file browser list. If you open up the file browser and you click the little like refresh list this folder icon or right click and task it, what Mythic does is it looks to see if you have any command loaded in that callback that says that the command supports file browser list. If it does, take those parameters, automatically issue that task for you. That's how Mythic is able to do a lot of this UI task buttons, because it's kind of this accepted like way of messaging between Mythic and these commands. So there are some that are always present in Mythic, like if you go into the callback list and say exit, it has to know what command to actually issue for you. So all this stuff is automatically tracked. You as an agent developer can also say, I support, Bloodhound member of, or I support Ghostwriter add report. Like you can define whatever these things that you want are, and you can use them in your own tasking. So what we can do is, as part of Bloodhound, we can say, you know what, for every edge, I'm going to go ahead and define a new UI feature where I'll return whatever is meaningful for the edge. So maybe for some edges, you give the source and destination. For maybe others, you give source, destination, and service principal name, like all sorts of stuff that you can define. And then other agents can say, hey, I support that. If somebody does that, tell me. I got you hooked up. I will execute a command for you. So looking here specifically, we can say the 2 highlighted pieces here, what UI feature, in this case, Bloodhound something. And then the nice thing down there is select callback true. Normally, Mythic looks in the same callback that you're executing to see what kind of commands you want to do as follow-on. That doesn't make sense for Bloodhound because we're not trying to task Bloodhound to run commands for us. So you say select callback, and we'll automatically get a pop-up that says, what callback do you want to task. Here's another example down here where we, as part of this graph view rendering, we say, oh, hey, this node that we got back has service principal names. I'm going to go ahead and loop through them, and for each one, I'm going to add a button that says curb roast to this service principal name. So you can just right-click a node and say curb roast and do the thing for you. And you can see that manifesting down here. We had these already by default, and now we added, hey, do this curb roast. So this is a quick little video going through showing that we are in an Apollo callback that has some commands loaded in for us. We're going to go to our Bloodhound callback, look at this node. We'll go ahead and turn off the browser script so it doesn't render the graph, but you can see the raw data that Bloodhound's API returns. And you can see as part of these properties has SPN, and we have a list of service principals. Sweet. So as part of our rendering for this graph, we have decided that we'll go ahead and add a context menu option for you to say curb roast. So that goes through, and if we have in another callback a supported UI feature, in this case, Bloodhound : curb roast, then we'll go ahead and execute that command for the callback that we specified with the parameters that we identified. So it goes over here, and for that Apollo callback, automatically issues this execute cough command to then pass in these parameters and do everything there. So we're able to go through, and this is a test domain, so it doesn't actually have that, that service principal in it, but what we're able to do here is automatically task other callbacks directly based on the data that we're getting back from Bloodhound. So it shortens that loop for you. That makes things a bit easier. Come on. Yeah. So then the last one I want to talk about is Nemesis. So this is a relatively new project from Will and Lee. Really, really awesome. Does a lot of enrichment and file processing and data processing for us. You can connect this up through a lot of different agents and stuff that way. You can normally process downloaded files, process data, and certain registry and seatbelt data as you go through and doing your ops. In Mythic, by default, if you set this up with the Mythic connector, Nemesis will connect back into Mythic and give you tags of data. So here we're looking at a process listing where Nemesis has generated tags for these various processes that says, like, this is normal infrastructure, this is an agent, this is a browser, here's things to know about the context in which you're getting back. If you're looking at things like a file, then Nemesis will add in all sorts of stuff about this is a DP API predicted blob, this has Nosy Parker results, like this has general file metadata, and it can give you links right into Nemesis for things like if you want to download the file, if maybe this was a Word doc and Nemesis created a PDF, you can get a link directly to that from Mythic, all sorts of stuff, really, really handy. But that is Nemesis into Mythic. Here we're talking about Mythic into Nemesis. Can we, from Mythic, query the Nemesis API and get data? So here we can go through and kind of reduce some of the overhead of going through and clicking into various different platforms. So just very recently, Nemesis added in the same sort of API that Mythic and Ghostwriter uses, which is Hasura, a GraphQL API. So we can go ahead and hit that and start fetching a lot of this data that Nemesis is aggregating for us and start displaying it. Unlike Ghostwriter and stuff like that, where you generate a user-specific API token, with Nemesis, you have a basic auth, username and password. So that's the stuff that you would set up as part of your user secrets, and then you can start connecting in. So here we can see, as Nemesis is going through and processing master keys and decrypting Chrome data, we can just issue Chromium and say, hey, you know, what things have you gathered so far? And because we can render this as tables, you can just click a password and use it, or you can just click around the various data that's getting returned. Same with going through and looking at the various hashes that you're getting back. Have any of these been cracked? What's the cracked one? Maybe I want to take it right from here and add it to Mythic's credential store and then use it as part of tasking. Like all sorts of stuff directly right here in the UI. Same with if you want to go ahead and take arbitrary other files and upload them as part of Nemesis, you can do it right here in the UI as well. Provide a file, upload it, get it ingested, and start having it processed on the back end. Going forward, Nemesis is going to expand and provide more functionality for you. And so then we can start doing further manipulations. Instead of just querying Nemesis for data, let's start pushing data. If we got maybe passwords from screenshots or key logging or stuff like that, that's not in a file or something that's automatically processed by Nemesis, let's tell Nemesis about it and then have Nemesis kick off that processing. So we can do a lot of stuff with this as Nemesis API starts expanding and getting more and more stuff in there. So to kind of wrap up these third-party accesses, you get per user access whatever it is that you're trying to do. You get graph or like API level access to whatever it is that you're trying to do, but you can then take it around and make it something more human readable or human usable with Mythic's browser scripting, whether that be tables, buttons, graphs, like all sorts of stuff. You get automatic tracking, you get collaboration, you get all this sort of stuff that now everybody on your team can see what's going on and update and work together more efficiently on it. And of course, all these things right here, the Nemesis, Ghostwriter, Bloodhound, and Arachne are all published on the Mythic Meta website. It's all available, all open source. You can pull it down today and play with any of it. And of course, because it is open source, I am always accepting PRs, and as people find more things that are fun to play around with, always happy to collaborate and get that stuff added into the agents. So that's right on time, I think.
We have a little bit of time for some questions if anybody has any.
So when you're developing features, how do you balance third-party integrations and the amount of work you're duplicating? You reinvented a lot of the Bloodhound UI. Like, how do you judge that level of workload versus just pitching off and say, use the Bloodhound UI instead?
Yeah, that's a great question. So I try and look at it if there's additional context I can get as part of re-implementing or re-adding that. So Mythic already uses a graph library for viewing callbacks. So adding in a graphing library wasn't something new. All I did was just create like a React node that says like, here's how you render this thing. But the benefit I get from that is more agents can now use that. So if you have other data that makes sense to represent in a graph, you can use that without having to figure out how to add that into like Bloodhound's UI. And we get additional features from it. So like the ability here to be able to just right click a node and say, task my already existing Apollo agent to do this thing. I think that is a high enough bar of like user feasibility and like effectiveness that it's worth doing. If it was just like displaying the UI, maybe not as much, but yeah.
So I guess the follow-up question is, so what made you choose to put that in Mythic rather than just adding the integration in Bloodhound's existing UI? So you have Bloodhound up and you have that edge connection, but instead Bloodhound tasks Mythic rather than Mythic tasking itself.
I think it's easier to have the agent identify everything that it needs outside of needing Bloodhound to know about how Apollo does something versus Merlin does something versus something else. It's easier to keep as much of that as possible within the agent developer's realm. And so it's easier for them to create their own agent and do things that way than trying to get maybe something else that they want to add it in, getting Rohan and the Bloodhound team to get that added into their roadmap over file upload sizes or whatnot.
Cool, thanks.
Yep.
Other questions?
Hello. So when you were talking about Arachne earlier, you had mentioned that it used like AES 256 and that the keys were not, there was no key exchange. So my question is, do you dynamically generate those per like a web shell that you would run, or how does that work?
Yep, great question. So as part of Mythic in general, if you say that you support AES 256 encryption, whenever you generate a payload, a new encryption key gets generated every time. And so you can, for every new Arachne payload you generate, you'll get a new encryption key as part of that.
Okay, perfect.
And I didn't do it for Arachne this time, but because a web shell and web is stateless, if you wanted, you could code things up so that you generated cookies and save those back and forth so you could do that sort of encryption key exchange. You just have to make sure that you keep track of that cookie and don't lose it. Otherwise, you'll lose the ability to task. But yeah.
Cool, thanks.
Mm-hmm.
One more? Well, Cody, thank you very much. Let's give him a round of applause, y'all.